So today we're doing Lewis dot structures for covalent bonds. So first we're just going to review with how do we do Lewis dot structures. So if you remember, what we do is we use our periodic table to represent the number of valence electrons, and we place those around each element. So fluorine, if we go and look and find it on the periodic table, it's in group 17, so it's going to have 7 valence electrons, and we represent those with dots, and we place them around the outside of our fluorine. And so same thing would happen for chlorine. It's also in group 17, so because that's going to have 7 valence electrons. And I put 1 on each side, and then we start doubling them up. This is what our Lewis dot structures would look like just for each individual atom. But they're not happy that way, so we want to think about how, for a covalent bond, can they bond in order to make both elements happy. And for them to be happy, they both need to have an octet. So right now, fluorine has 7 valence electrons, and chlorine has 7 valence electrons, so neither of them are very happy about that. So what we can do is we can scoot them over and actually make something called a bond. And so each bond, we have 1 of these electrons from fluorine, 1 of these from chlorine, and they're going to make a bond connecting those 2 atoms. Another way to draw that is by showing the 2 electrons that are being shared as dots, and then all the other ones are around each atom. But either way, it's showing that for fluorine, it's using all of these electrons, so the 2 that are in that bond, plus the 3, 4, 5, 6, 7, 8. So now it has 8 electrons. So now it has 8 electrons and is happy. And chlorine also has, it's 6 plus these 2 from that bond, so it has 8 electrons. We can also show that up here, showing that they're both sharing those 2 electrons. And you will see it either way. You can draw the bond either way with the dots or with the line, but the one that is most likely to be seen is the one with the line, because it just makes it a little easier and not as messy to see what's going on. So what about for fluorine and iodine? So you take a second to figure out what you think would happen for these 2. Fluorine again is going to have 7 electrons, or valence electrons, and iodine also has 7 valence electrons. So what's going to happen is that this fluorine will come over and it will share that these 2 electrons, or we could draw it this way. Either one. Okay, so now I want you to think about what about for other elements that are not in group 17. So fluorine here is going to have 7 valence electrons, but oxygen, because it's in group 16, has 6. So think about what's going to happen to make these 2 bond together. And what you might find is that you could take fluorine and bring it over here just like before to make a bond here. But now we just have 1 electron over here all by itself. So it's not going to be able to bond to anything because we have to have 2 electrons. So our bond is going to equal 2 electrons. We don't have another electron, and fluorine, this fluorine is happy, and the oxygen is unhappy. Moving any electrons over to this bond would make fluorine unhappy. So what we would have to do in this case is add another fluorine in order to have a bond. But just what you're thinking about, we have to make sure that both elements are happy in order for it to work. Okay, so we have these steps that I'm going to work through with you so that you know this procedure to make sure that you understand how to draw a Lewis dot structure for all situations. So the first thing we need to do, number one, is to find the total number of valence electrons. So our example we're going to use is CH4. So for our valence electrons, we're going to think about each individual thing. So we have carbon is in group 14, so it's going to have 4 valence electrons, plus our hydrogen has 1 valence electron. So we have 4 hydrogens. So altogether, our valence electrons are going to be 8. This is how many electrons this whole compound, all the electrons that are being brought to the table. That's the first step. The next step we need to do is find the number of electrons needed to make atoms happy. So this is not wanting how many electrons need to be added in addition to their valence electrons, just what is their total number. So maybe we should write that down. And what's the total number of electrons needed to make it happy? So our happy number for carbon wants to have an octet. So it wants to have 8 electrons. And for all elements, this number for this calculation is going to be 8. Except for our exception is hydrogen, which since it only has its first energy level, it is only going to need 2 to be happy. And then we have 4 different hydrogens. So all together, we want 16. So we need this number of 16 in order to figure out, okay, if each thing was by itself and not bonded and not sharing electrons, we would need 16 electrons total. But we don't have that. We only have 8 electrons. So how we figure that out what to do is by creating bonds. So this is the two numbers we need to figure out the total number of bonds, which is our third step. Determine the number of bonds. And so to do that, we use the number of electrons needed to make the atoms happy, or our octet number. So this is basically just the number that we got from number 2, minus our valence electrons. That was our number from number 1. And then we divide that whole thing by 2 because each bond is made of 2 electrons. So we want to find the number of bonds. And once we figure that out, it makes drawing the structure a whole lot easier. So some will become, you will be able to look at and right away figure out the structure fairly easily, but this will help us on even ones that are not as straightforward and easy. So our bond number, we had to calculate those 2 numbers from before. We're going to do 16 from here, minus 8, and that whole thing divided by 2. So we figure out that we are going to have 4 bonds. So the next thing is we need to choose a central atom. And the way we do this is we figure out the thing that has the most bonding sites. So let's look at our options. We have carbon and we have hydrogen. Those are the 2 options we have. What's going to go in the middle? Another rule of thumb you could think about is the thing that's by itself, so there's only one of often is the thing that's in the middle. But in this case, hydrogen only wants to have one other thing, so it's probably only going to bond with one other thing. Carbon, on the other hand, has 4 valence electrons it needs. So it is the possibility of bonding with 4 things. So because of that, carbon is going to be our central atom, and we're going to place it in the center. And so from there, we just put things around the outside and start making bonds. And this is a pretty simple one because we have 4 different bonding locations on our carbon, and we have 4 different bonds. So each of these, we can put a hydrogen because we also have 4 hydrogens. And if you notice that each of these 2 now are able to make a bond. And we can double check to make sure everybody's happy. So hydrogen here has 2 electrons. It has 2 from this bond. So it's happy. Same with all the other hydrogens. They have 1 bond, so 2 electrons, so they're happy. And then each of these bonds for carbon is 2, 4, 6, 8 electrons, so that also makes carbon happy. So all of our atoms are happy. And so this is how we would draw the Lewis structure. And then I guess that was step number 5, was to draw it. So first we put in our bonds, and then we're going to put in any extra electrons. In this case, we don't have any other extra electrons afterwards, and actually it's a good idea to go in and double check to make sure we have all of our electrons counted for. Because we should have 8 electrons in this whole structure, and we do. We have 2, 4, 6, 8. 2 for each of the bonds. So we do have all of our electrons. We don't need to go back in and add any more. But there is one last thing that we need to do, and that's calculate something called formal charge. So this is helpful for certain cases when we have our Lewis dot structure isn't exactly what you would initially think because of the formal charge of an atom. So we want to have the smallest formal charge, and ideally we want that formal charge to be 0. And we can use this equation, or I can show you kind of a simpler way of thinking about it. It depends on if you want to think about it in math terms or in non-math terms, I guess. So anyway, this is saying that the formal charge is equal to the valence electrons minus LP, here stands for lone pair electrons. And this is when we just have dots next to things and they're not being bonded. And that's what that's talking about. And then we have BP, which stands for our bonding pairs of electrons. And so this is the electrons in that bond. So we have 2 electrons for every bond. And then we divide that by 2 because each bond itself is being shared between the 2 atoms. So how we would do this for this example is we would write the formal charge for each individual atom. So for hydrogen, its valence electrons is 1. It brought 1 electron to the table. And then we're going to subtract using that equation. I'm going to first show you what the equation and then kind of show you what the equation is doing to help you think about what's going on. The equation is looking at how many lone pairs of electrons. And so we don't have any electrons out to the side of hydrogen, so in that case we have 0 of those. Plus how many electrons are in a bond. So we have 1 bond attached to hydrogen, so that's 2 electrons, but we have to divide by 2 because for this bond, even though, yes, 2 electrons are going to hydrogen, it's sharing that, so it gets half of it. So this equals out to 1 minus 1, which is 0, which is what we wanted. We wanted our hydrogen to have a formal charge of 0. And you can kind of see fairly quickly that all the other hydrogens will have the same formal charge because it's pretty symmetric. Carbon, so for formal charge we have to give a number for each individual atom. So carbon brought 4 electrons, minus it has 0 lone pairs, and it has 2, 4, 6, 8 electrons from bonds, and then we have to divide that by 2. So it's also going to be 4 minus 4 is equal to 0. This is just another way to double check our work to make sure that everything is nice and happy and help us if there's any issues. So you can also think about doing this as you look at how many electrons it's bringing minus how many it currently has. So you count all the electrons around carbon, and then if it's a bond, it only gets half. So it gets 1, 2, 3, 4 electrons because there's 4 bonds. So that means 0. And since it's 0, we really don't even write anything else on our Lewis dot structure. We just used it to check. So the answer would be the structure with our carbons and hydrogens. If the formal charge was not 0, then we would write an answer. Or we would write in like a plus or a minus depending on what the charge was. But for the most part, these are going to be 0s for right now. So let's practice another example. So we have carbon dioxide. So our step number 1 is to find the total number of valence electrons. So our valence electrons, carbon is going to have 4 plus oxygen, which has 6, and then we have another 6. So altogether, this one's going to have 16 valence electrons. Then we look at the number needed to make everybody happy. So in this case, carbon would like to have 8 electrons. Oxygen also, and there are 2 oxygens. So we're going to have 24 electrons needed to make everybody happy, which we don't have that many. We only have 16, so we need to figure out how many bonds are we going to have in order to make everybody happy, because we have to have some sharing going on. So our number of bonds is going to be 24 minus 16 divided by 2. So we're going to have 3 bonds. Oh, I'm sorry, I didn't do that wrong. You're going to have 4 bonds. Okay, so this makes it a little easier for us to figure out what's going on. So now that we have figured out the number of bonds, which are 4, not 3, we need to figure out what element is going to be, or what atom is going to be our central atom. So we have carbon, and we have 2 oxygens. And so we're looking for the thing that has the most bonding sites, and that's still going to be carbon. It has 4 areas where it can bond to things. Oxygen only has 2 each. So we're going to put our carbon in the center. So then we're going to put everything else around it. So we'll put an oxygen next to it, and we will also put another oxygen next to it. So we can see some pretty obvious bonds right here. We can see a bond here and a bond here. But this doesn't really make anybody happy. Carbon now has 6 electrons, and it wants 8. And oxygens have 7, so they're not happy yet. And we know that we're going to have 4 bonds. So what we can do is we can actually use one of these electrons over here. We can actually use 1 electron from our carbon to bond to another electron from our oxygen, and then the same thing to our other oxygen. Another way we could write this, it's a little more clean, is this. So we want to double check to make sure that all of our electrons are counted for. We have 2, 4, 6, 8, 10, 12, 14, 16 electrons, which is how many we're supposed to have. And then is everybody happy? Let's see, oxygen has 2, 4, 6, 8, so it is happy. Same with the other oxygen. And carbon has 8 electrons as well, so everybody's happy. So the last thing we have to do is to check the formal charge. Okay, so formal charge for oxygen, it brought 6 electrons to the table, and it currently has 1, 2, 3, 4, 5, 6 electrons, because it only gets half of those bonds. So because of that, our answer is 0, so it has a 0 formal charge, which is what we want. And then carbon, it brought 4 electrons to the table, and then it gets 1, 2, 3, 4 electrons, so its formal charge is also 0. So your answer, you have your formal charge to the side to calculate it, but your answer would be this structure. Okay, we're going to try one more. So that's when we have C2H2. So first thing, we need to figure out number of valence electrons. So carbon is bringing 4, and we have another carbon. hydrogen is bringing 1, and we have another hydrogen. So we're going to have 10 electrons. Then we're going to look at how many electrons everybody needs. So carbon wants 8, we need another carbon, hydrogen wants 2, and we need another. So we want 20 electrons if everybody's by themselves, but obviously we can't because we only have 10 electrons, so because that we have to bond. So our number of bonds is going to be 20 minus 10 divided by 2. So we're going to have 5 bonds. So we have 4 different elements this time. So our hydrogens are always going to go on the outside. That's another little trick about hydrogens. They're always going to go on the outside. They're never going to go on the inside because they only have 1 electron. It's only 1 binding place. Carbon has 4 electrons, and we have 2 different carbons, so it doesn't really matter which one we pick as our central atom. So then we can place our other carbon around it and draw a bond. We can draw this hydrogen over and draw a bond. And so you might think initially that this hydrogen is going to go over here around the central atom, but it actually isn't. It's going to move over here. And I guess a way we could use to figure this out is because it's going to be symmetrical if it can, especially if we have 2 of the same element for our central atom. Let's actually move this guy down. Okay, so right now our hydrogens are happy, but our carbons definitely are not. They only have 6. So what we're going to do is these 2 electrons can make a bond, and then these 2 electrons can make a bond. So another way to write this. So we have 5 bonds, which is what we had anticipated. And do we have the right number of electrons? 1, 2, 3, 4, 5, 6, 7, 8, 10. We do have the right number of electrons. And then we need to make sure everybody's happy. Hydrogen has 2 electrons, carbon has 8 electrons, so everybody is happy. The only thing we have left to do is our formal charge. So hydrogen brought 1 electron, it currently has 1 electron, so its formal charge is 0. Carbon brought 4 electrons, and it currently has 4 electrons, so its formal charge is 0. So this is how we would draw our Lewis dot structure for this. And this might seem overwhelming, but if we practice it more and more, it'll make more sense and be more intuitive, and you can figure out structures really quickly. So that was the last of our examples.